Elementary Algebra, Assessment 3 Review, Questions 6, 7, and 8. In question number 6, the instructions read, write the equation of the line connecting the given points in slope-intercept form. What we're given are 2 points. If we have 2 points, we can calculate the equation of the line using the point-slope formula. But first, we have to get a slope from the 2 points. So we're going to use the slope formula. We have a y sub 2 minus a y sub 1 over an x sub 2 minus an x sub 1. What we're going to do is assign one of these as our first ordered and the other as our second ordered. So what I'm going to do is just keep them in the order they're shown, the 2 points. So the first one shown will be my first ordered. The second one will be, of course, my second ordered. So coming over here, my y sub 2 comes from my second ordered pair, so it's a 5, minus the y sub 1, which is a 0, which comes from my first one. We do the same thing in the bottom with the x's, so I take from the second one the negative 4 minus the positive 7, and I solve it out. So I end up with a 5 over a negative 11. Now that I have a slope, I can plug the information into the point-slope formula, which is y minus y sub 1 equals an m times an x minus x sub 1. I'm going to pick one of the 2 points that I was given. It doesn't matter which one. Sometimes it's easier to look for the one that has the smaller numbers. Keep the math really simple. So I'm going to choose the 7, 0 and plug it in. So I'm going to scroll this down a little so we can see it a bit. So for my y, I had a 0, so I plugged it in on the y sub 1, equals the negative 5 over 11, that's the slope we just calculated, times the x minus the 7 from that ordered pair that I selected. So from here, I just need to start simplifying. Well, a y minus 0, that just leaves me with a 0. On the other side, I need to clear the parentheses, so I'll distribute the negative 5 over 11 through the parentheses to the x, and then distribute it through the parentheses to the 7. So what I'm doing is multiplying these together. So in the second step, I'm showing that I took that 7 over 1 times that negative 5 over 11. When I multiply them together, I end up with a y equals a negative 5 over 11x plus a 35 over 11. I've written the equation of the line in slope-intercept form. For question number 7, the instructions read, write the equation of the line that passes through the given point and is parallel to the given line. Write the equation in slope-intercept form and in the form of ax plus by equals c. This is called the standard form, where a, b, and c are integers and a is greater than a 0. So let's look at this problem. So for number 7, we're given the point 10, 7. We know that that point is on our line, and we're also given the equation of a line 2x minus 5y equals negative 5, and this one runs parallel to ours. Well, when an equation runs parallel, or when a line runs parallel to another, the thing that they have in common is the slope. Their slopes are identical. So if we can find the slope from this line, we can find the slope for our line. Before we can do that, though, we need to rewrite this into slope-intercept form. That means that the y needs to be isolated to the left on its own. So we're going to start by getting that 2x out of there. We're going to subtract it off both sides so that we're left with a negative 5y equals a negative 2x minus 5. Second, we're going to divide out that negative 5 so that it clears off the left side. But whatever we do to one side, we have to do to the other. So both terms on the other side get divided by a negative 5. So once we clear it up, a negative 2 with a negative 5, that makes a positive 2/5 x. A negative 5 divided by a negative 5 makes a positive 1, or plus 1. So the slope of this line is 2/5. That means that the slope of our line is 2/5. So now we can use the point-slope formula, y minus y sub 1 equals m times x minus x sub 1. We're going to plug the point in that they gave us and the slope that we just found. So we end up with a y minus 7 equals a 2x times x minus 10. Let's start by simplifying, so I'll distribute that 2/5 through the parentheses. I end up with a 2/5 x minus a 20 over 5. Now I need to move that 7 away from the y, so I'm going to come back here and I'm going to sum the 7 to both sides. So this is going to result in a y equals a 2/5 x plus 3. So I found the slope-intercept form, so I've answered half the question. The other half says to put it also into a standard form, which is the ax plus by equals c. So that means I need to move this x to the other side. So I'm going to subtract the 2/5 x from both sides of the equation. This negative 2/5 x and y are not alike, so I'm just going to hold them in the position that they should be in the standard form, ax in the front, the y in the back. Now, I'm pretty close, but I'm not meeting the rules. It said that the a position, the b position, and the c position all had to be integers. I can't have a fraction or a decimal. And in this case, I've got a fraction right here, so it's going to have to go. The other set of the instructions said that the a position had to be greater than 0. With it being a negative right now, it's less than 0. So I also have to clear that negative. I'm going to clear the fraction by looking at all fractions present and multiplying by the lowest common denominator. This one's simple. Since it only has one fraction present, the lowest common denominator is the denominator of the fraction present, which is a 5. I'm also going to make sure that that's a negative 5 so that I clear that negative off the front. So I multiply everything by a negative 5. So I come in here, a negative 5 times a negative 2 makes a positive 10. If we were looking at this 5 like it was over a 1, then a 1 times a 5 makes the 5 here. So 5 into 10 makes 2x. A negative 5 times a y makes a negative 5y. A negative 5 times a positive 3 makes a negative 15. So here's our second part of the answer in standard form. Moving on to question number 8, this one says write the equation of the line that passes through the given point and is perpendicular to the given line. Write the equation in slope-intercept form and in the form of ax plus by equals c, where a, b, and c are integers and a is greater than 0. So this one's going to be just like the last problem, except for this time our line is perpendicular to the line that was given. That means that it's going to have a slope that is the reciprocal in the opposite sign. So if it is a positive, it's going to be a negative, and it'll be the reciprocal of that value. So again, just like in the last one, we isolated the y to get this into slope-intercept form. So running through the procedures, we end up with y equals 2/5 x minus 6 over 5. So ours is going to be the opposite sign, so it's going to be a negative, and it's going to be a reciprocal of this, so it's a 5 over 2. So this is our slope. So knowing that and knowing the point, we can plug our information in. So we end up with a y plus a 1 equals a negative 5 over 2 times x plus 7. We're going to distribute again this m value through the parentheses to clear. So we end up with a negative 5 over 2x minus a 35 over 2. Next, I'm going to move this 1 over here. I move it over by subtracting it off both sides. Well, when I subtract it over here, I would end up with a 1 over a 1. I can't combine these two quite yet without a common denominator. So a common denominator here would be a 2. So that means whatever I multiply the top by, I would multiply the bottom by. So that's how I ended up with this 2 over 2. It was originally a 1 over 1. It was the 1 over here that I brought over and subtracted. And I multiplied the top and the bottom by 2 so that I had a common denominator between the 35 over 2 and the second one. Now I can combine them, so I end up with a negative 35 and negative 2 for a negative 37 over 2. So now I have this problem written in slope-intercept form. I'm halfway there, so I've got half the answer. Now I'm going to move on, and I'm going to turn this into standard form. I'm first going to move the negative 5 over 2x to the other side by summing it. So this leaves me with a 5 5 over 2x plus a y equals a negative 37 over 2. This time I have a positive in the front, so I meet part of the requirement, but I still have fractions present, so I'm going to multiply by the lowest common denominator to clear those fractions. In this case, they're both the same, so it's going to be a 2. So I'm going to multiply both sides by a 2, so 2 times 5 for 10. And then this 2, remember it's over 1, so 1 times 2 for a 2. And carry down the x. Carry down the plus sign. A 2 times a y makes a 2y. On the other side, again, just put it over a 1. 2 times a negative 37 makes a negative 74. And a 1 times a 2 makes a 2. Now what I can do is divide those 2's in. So a 2 into 10 to get a 5x plus 2y equals, on the other side, divide the 2 into the negative 74 to get a negative 37. Now it's in standard form. I've completed the question.